Hey there, welcome to a quick video on vertical asymptotes. So today we're going to talk about vertical asymptotes, but kind of giving away the game here and telling you what you're going to see before you're going to see it. So, there you go, I've ruined the surprise. But really, we are going to talk about vertical asymptotes and how they relate to limits. So on this first one, you'll notice examples 1, 2, and 3 don't say anything about vertical asymptotes because what I want to do is I want to connect the algebra of the limit to what the numbers are doing, to what the graph is going to look like. Again, that rule of 4, got to talk about the math that's happening with algebra, numbers, and graphs. So on this first one, it says find the limit as x approaches 3 from the right of x minus 8 over the absolute value of x minus 3. And I'm going to follow the rule that says that math and absolute value do not like each other. So I am going to rewrite x minus 8 over the absolute value of x minus 3 as x minus 8 over x minus 3 for when x is greater than 3, because if x is bigger than 3, I don't need the absolute value anymore. And x minus 8 over negative x minus 3 for when x is less than 3, because when x is smaller than 3, the absolute value has to negate the negative to make it positive. And I can't underline either of those because if x were to exactly equal 3, I'd have a 0 in the denominator. So then the question says, find the limit as x approaches 3 from the right, and that limit is going to be the same as the limit as x approaches 3 of, let's see, if I'm coming from the right, x minus 8 over x minus 3, which is negative 5 over 0. So that limit doesn't exist, but I want more than that, okay? Calculus is all about, well, yeah, I get that the limit doesn't exist, but tell me more. Don't just say undefined. Let's do better. So as x approaches 3 right here, and I want x to approach 3 from the right, if I'm to the right of 3, 3 minus 8 is negative 5-ish. Because x doesn't actually equal 3, it's close to it. And in fact, it's just a little bit bigger than 3. And as x approaches 3 from the right of x minus 3, 3 minus 3 is 0-ish, because I'm not exactly at 3, I'm a little bit bigger than 3. And so I'm going to say, wait a second, 0-ish, is that like a little bit more than 0 or a little bit less than 0? And so if I come at 3 from the right and plug it in right there, I have like 3.00001. And 3.00001 minus 3 is heading towards 0, but it's actually a little bit bigger than 0. So that's really like 0-ish and positive. So if I take negative 5 and I divide it by a number really close to 0 and positive, a negative divided by a positive is going to be negative, and negative 5 divided by 0-ish gets really big. You're not allowed to divide by 0. That's undefined, full stop. But if you divide by 0-ish, that you can do. And if you take a number and divide by a really small number close to 0, a number divided by a number close to 0 goes toward an infinity. And in this case, I took a negative 5 and I divided it by a positive 0. Yes, I know those don't exist, but a negative 5 divided by something positive and close to 0, that's going to get me negative infinity. Okay? So the answer to this initial limit is negative infinity. And what does that mean? It means that I should be able to draw a graph. And now I know on that graph, as I come at 3 from the right, my graph is going down to a vertical asymptote. Okay? So again, things I need you to take away from this example, okay? If I had things in a nutshell, I need you to know that a number that's not 0 divided by 0-ish is going to head toward either positive or negative infinity, depending on whether the number is positive or negative, and that 0-ish is positive or negative. So I need you to know a number divided by 0 is going to head toward infinity in a limit sense. And if you have a limit as x approaches a number, and you get either positive or negative infinity, that means that the graph has a vertical asymptote at x equals a. So dividing by 0-ish gets you to go to infinity. And if as x approaches a, you go to infinity, then x equals a is a vertical asymptote. Okay? Okay, so there's all my explaining. Now let's get to doing. The limit as x approaches 2 of x plus 3 over x minus 2. Okay, well, if I were to just plug in 2, I'm going to have a 5 on top and a 0-ish on the bottom. But I don't know if that's a positive or negative 0 because this just said x approaches 2. It didn't tell me about from the left or from the right. And that, I think, is going to make a difference here. So I'm going to say, wait. 5-ish divided by 0-ish is some kind of infinity, but I don't know which kind until I look at both sides of 2. So I'm going to say, you know what? I actually can't answer this right now until I split this into 2 limits. I need the limit as x approaches 2 from the left, and I need the limit as x approaches 2 from the right. All right, so as x approaches 2 from the left, 2 plus 3 is 5-ish. 2 from the left, that's slightly smaller than 2, so like 1.999. 1.999 minus 2 is going to be like 0-ish and negative. Positive 5 divided by negative small is going to go to negative infinity. And as I approach 2 from the right, 2 plus 3 is still 5. 2 minus 2 is still going to 0, but this time I'm slightly bigger than 2. Slightly bigger than 2 minus 2 is going to give me a positive number. 5-ish divided by positive 0-ish is positive infinity. So from the left of 2, I go to negative infinity. From the right of 2, I go to positive infinity. Therefore, the limit as x approaches 2 does not exist, because my left limit and my right limit went to different places. But what does it mean that that limit does not exist? Graphically, it means that if I go towards 2 from the right, I head to positive infinity. As I go towards 2 from the left, I go to negative infinity. And there it is. All right, let's do it again. As x approaches 0, again, this isn't sided, so I'm going to break it up and say, all right, as x approaches 0, I'm going to take the limit as x approaches 0 from the left. I'm going to take the limit as x approaches 0 from the right. And then say, okay, if I approach 0 from the left, 7 times 0 is 0, minus 2 is negative 2. And 0 squared is 0, except I'm squaring that 0, so it's 0-ish, but it's got to be positive because I've squared it, right? So even if I'm coming at 0 from the left, like negative 0.001, when I square it, it's negative 0.00001, but positive, because a negative times a negative is a positive. So that's negative 2-ish divided by positive 0-ish. That's going to go to negative infinity, because a number divided by a 0 in a limit sense is going to go to infinity. And then if I do it again with 0 from the right, 7 times 0 is 0, minus 2 is still negative 2-ish, divided by 0-ish. But because of the squared, both of these denominators are positive as x goes towards 0, which means both of these limits go to negative infinity, which means my limit as x approaches 0 of 7x minus 2 over x squared equals negative infinity, which means our graph goes down on both sides. Okay? Okay. Number 4, it says write limits describing the graph of f around negative 4, 0, and 9. Okay, well, let's look. Negative 4 is right here. Well, negative 4 is doing different things from different sides, so I should probably write 2 limits and say the limit as x approaches negative 4 from the left of f of x. Well, let's see. Negative 4 from the left is coming up towards 1. And the limit as x approaches negative 4 from the right is coming up toward negative 3. And if you really wanted to do more with that, you'd say that means the two-sided limit as x approaches negative 4 does not exist. And then if I look at 0, there's a hole there, but the limit from the left and the limit from the right both go to the same place. So I'm going to save myself some time and just say the limit as x approaches 0 from both sides of f of x gives me a y value of negative 5. And then if I want to look at the limit as x approaches 9, I can only come from the left. So as x approaches 9 from the left for f of x, I am going also toward negative 5. And you know what? Let's add a 4 in here. I really wish I had asked for 4 also. So let's look at 4 as well. That's that guy. Well, there's clearly a vertical asymptote at x equals 4. And both sides go up. So I could say the limit as x approaches 4 goes to infinity. And there you go. And then on the back, we're going to go backwards and say, all right, now that we've done all this stuff with limits, what if I take the limits and then have to draw a graph? And that's what we're going to do back here. So let's see. If you want, you could pause the video right now, draw your own graph, and then scrub forward and see if yours looks like mine. So pause. Or don't, and do it with me. So let's see. The limit as x approaches 3 of g of x is 5. Okay, so at 3, I know my limit goes toward 5 on both sides, okay? But I don't know if that's a filled-in hole or a not filled-in hole, so I'm just going to say I've shown that the limit goes to 5 on both sides. But right beneath it, with an extra parenthesis for some reason, right beneath it, it says g of 3 is supposed to equal 2. So g of 3 has a dot at 2, which means my limit is a removable discontinuity with a hole, and the function actually equals 2 somewhere else. Okay, done. As x approaches 0, the limit for g goes to 1. So as x approaches 0, the limit for g goes to 1, but g of 0 is 0. Okay? As x approaches 4 from the right, g of x goes to positive infinity. Okay. anytime a limit goes to positive or negative infinity, as x approaches a number, that means I've got a vertical asymptote there. So from the right of 4, I am going up along that vertical asymptote. And coming at 4 from the left, I also need to go up. So this must connect like that. And coming at -2 from the right, g of x needs to go to negative infinity. Okay, so coming at -2 from the right, g of x needs to go to negative infinity. So what I'm going to do is just connect these and then go down to negative infinity. And let's see, 4 from the right. Well, I already did that one. That shouldn't have been there twice, so just cross it off. All right, I made a mistake in the notes. Just cross that one off, it's fine. So let's see, it says sketch a graph of a function that satisfies these. So you know what, I'm just gonna kind of let this thing do whatever it wants. I have no idea if my graph exists on this side of that asymptote, so I'm just gonna leave it blank and say here, this is a graph of a function that satisfies each of the following. I have a limit as x approaches 3 that goes to 5. I have a limit as x approaches 0 of 1. I have function values at 2 and 0. I have a vertical asymptote that applies to both sides of x equals 4. And I have a vertical asymptote from the right-hand side of -2. And everything's done. And that's it. So I'm going to stop this video here so that you do not need to listen to me go on and on about it. Have a great day.